Welcome to the Cloud Data Integration, Concepts and Architecture course. Hello, I'm Laura, and I'll be your guide through this training. Up in the right-hand corner, you'll notice a resources area. These resources will supplement and support this course. At the end of the training, there is a quiz. This quiz is designed to provide direct feedback on your knowledge of the content presented. You are always welcome to go back and review any of the information presented in this course. At the end of the course, you will be presented with a survey. Your feedback is critical to the success and further improvement of our courses. Please take a moment to complete this very important step. Now, let's move on to the objectives for this course. The objectives of this course are: understand the IDMC architecture, and explain the unified platform with multiple services working together. Explain the cloud data integration solutions, with tasks and mappings. And explore the various runtime environments. Welcome to the Informatica Data Management Cloud Overview module. Informatica Data Management Cloud, in short IDMC, is a unified platform to manage, govern and unify your data on a single platform. Its cloud-native architecture consists of several core components, like security, access control, and repository services. Depending on the license purchased, several other services are added. These are all implemented as microservices. The execution environment can be configured on a local or hosted environment, or serverless. CLAIRE, Informatica's AI engine, delivers enterprise unified metadata intelligence, AI-powered data, and intelligent metadata automation to drive productivity for data professionals. The IDMC platform has extensive connectivity options, from local files and databases to cloud storage, from applications to messaging and streaming. Let's look into more detail in the following slides. IDMC is an integrated platform, where services are added depending on the customer's license. The core services to administer the environment can be grouped as administrator. This contains access control, managing runtime environments and connections, and monitoring the environment and processes. Data integration consists of the CDI service, where you can develop various tasks for data integration and synchronization, and build complex mapping logic. Mass ingestion creates flexible and scalable wizard-driven solutions to ingest data from applications, streaming sources, databases, and files to cloud storage or messaging services. Change data capture allows incremental loads based on changes in the source systems. Data quality can run profiles to understand data or validate against business rules. Cleansing and standardization based on rules or dictionaries can be used in profiles or data integration mappings. Application integration allows for real-time API-based integration across partners and customers, orchestrating business processes that can span various applications. Cloud data governance and catalog lets the customer catalog and manage their business and technical assets, managing ownership and stakeholders of data assets. Master data management involves creating a single master record for each person, place, or thing in a business, from across internal and external data sources and applications, to create a trusted view of business-critical data. Predefined data models for customer, product, and supplier can be modified, and other models can be created. Let's explain the detailed architecture with a diagram. The IDMC services run in the cloud, on AWS, Azure, and GCP. The metadata repository contains the customer's assets. Although the environment is multi-tenant, customers' information is strictly separated and secured. The users log into this environment using HTTPS and their user ID and password. Depending on the roles and authorizations, they can administer the environment or design assets like CDI mappings and task flows. To execute these mappings and task flows, a runtime environment is needed. The most common is a cloud secure agent, running behind the customer's firewall. Secure agents can be grouped in a secure agent group. Here the secure agent runs on a local environment, and can access local sources and targets. The local secure agent can also access cloud databases, file systems, or applications. Additional connector licenses may need to be purchased. Many customers will have one or more cloud environments, in AWS, Azure, or GCP. They can install a secure agent or group on servers in the cloud. Accessing cloud data assets is similar to using the local secure agent. Accessing local data assets may need additional configuration to allow access. The connections you define in IDMC fall in various categories. You have flat file connections, including FTP and SFTP, and also cloud file systems like S3. Database connections, either via the native drivers or JDBC or ODBC. Cloud databases and data lakes, like Snowflake, Amazon RDS, Azure DW. Applications, including SAP, Salesforce.com, Workday and many others. Web services, to retrieve or post data from web applications or interfaces. You define these connections in the Administrator, under the Connections tab. The parameters to configure vary per connection type. Credentials configured in these connections are stored encrypted in the IDMC repository. Most connection types have a test option to validate whether the connection can be established. IDMC offers various options for runtime environments based on the customer's requirements. The basic runtime environment is a secure agent running cloud data integration. Secure agents are hosted on premises or on cloud servers in the customer's cloud environment. These secure agents provide codeless data integration, executing the tasks and mappings developed. The customer manages the number, size and location of the secure agents. You can use the hosted agent to run tasks if the customer has the cloud runtime license. Informatica maintains this agent, and it is typically used for scenarios where source and target data reside in cloud applications and infrastructures. If access to local applications is needed, you must configure the firewall rules for hosted agent, or install a secure agent within the customer's network. For increased scalability, CDI Elastic was introduced a few years ago. The mappings are translated into Spark code, which is then executed on an Elastic cluster in the customer's cloud environment. The customer must install a secure agent on a Linux server in the cloud and set up the Elastic cluster in the IDMC administrator. IDMC will spin up compute clusters when needed using this environment. CDI and CDI Elastic mappings can both be executed in an advanced serverless environment. Informatica completely manages the Elastic compute cluster, using the Informatica infrastructure to spin up the compute clusters. There is no need to install a secure agent, although you will have to create a VPC in the customer's AWS environment. When you are ready, please move forward to the next section. Welcome to the Cloud Data Integration Solution module. The Cloud Data Integration Solution consists of two services within the IDMC platform. The first is data integration. Within the data integration service, you can configure various out-of-the-box tasks to move data from a source system to a target. Configuration is easy, but the transformation capabilities are limited. When more transformation is needed, you can develop mappings in CDI. Mappings have many transformations available to build more complex integration logic. The second service is mass ingestion. Mass ingestion lets you ingest large amounts of data from application, database, file, or streaming sources. A configuration wizard enables you to set up the ingestion process very quickly. Mass ingestion also supports change data capture. Cloud data integration is used in other IDMC services. For example, the Cloud Integration Hub uses CDI for its integration processes, and MDM SaaS uses CDI to ingress and egress data into and from the MDM data store. Here you see the list of task types when creating a new task. Replication, synchronization, and data transfer tasks are wizard-driven, easy configurable tasks to move data. The standard tasks and mass ingestion module goes deeper into these task types. Data masking allows for masking sensitive fields in the source to create de-identified test data from real production data. Use the mapping task to process data based on a mapping. In the mapping task, you set the execution environment, runtime parameters, and other advanced settings, like Spark properties for mappings created in advanced mode. Dynamic mapping tasks let you create and batch multiple jobs based on the same mapping. Use parameters in the mapping for connections, objects, field mappings, etc. Mapping tasks and dynamic mapping tasks will be covered in subsequent modules in this series. And finally, to integrate existing Power Center mappings into the IDMC process flow, you can use a Power Center task. Cloud data integration mappings offer the most flexibility in designing your data integration logic. A basic mapping like this one has one source and one target, with 0 or more transformations in between. This second example has two targets, and the router transformation in the middle will decide to which target the data will be written, based on the conditions you define. These targets can use different connections, so one target may write to a database, while the other writes to Amazon S3. And this third example shows a joiner joining data from two sources into one target. Like targets, sources can be of different types. The list of transformations is extensive. Expressions, lookups, joiners, and routers are most commonly used, but many more can be added. Adding cloud data quality logic in the mappings can be done by adding the CDQ transformation and specifying the CDQ function to call. You can use the functions in the transformation language to specify the business logic within the transformations. String functions, data cleansing, data type conversion, numerical functions, the list is extensive. Mappings can use parameters for connections, data values, and even transformation logic. The module parameters and dynamic mappings will cover this in detail. You can run mappings manually, but in production, you will use mapping tasks and task flows to combine the business logic into one execution flow. Mapping tasks allow you to set the runtime environment and define email notifications on success or failure. You can also add scripts for pre- and post-processing. Parameter files can be added in the mapping task. And, if licensed, pushdown optimization can be configured in the mapping task. A task flow combines one or more tasks into a process flow. Tasks can be of different types, like mapping tasks, assignments, file wait, or command tasks. You can place tasks in the task flow sequentially or in parallel. Decision tasks let you add logic based on the execution results, for example, to send a notification if the previous task has written errors. The task flow can also throw errors based on the outcome of tasks. You can schedule task flows, so that they run daily, hourly, or weekly, based on the business requirements. You can also start them using the command line. When you are ready, please move forward to the next section. Welcome to the Runtime Environments module. The Cloud Secure Agent is the local runtime environment installed on Windows or Linux. Refer to the product availability matrix on the support website to check which versions are supported. You only have to install the Secure Agent, upgrades will be done automatically. The Secure Agent checks whether updates exist for the installed services and will pull them from IDMC. There is no need to manually install or apply new versions. A Secure Agent group consists of one or more Secure Agents, to enable high availability and load balancing. You can also use Secure Agent groups to separate runtime environments for different departments or enabled services. Because the Secure Agent is installed behind the customer's firewall, it can access all local databases, file systems, or applications without opening ports in the firewall. The Secure Agent can be installed locally on physical or virtual servers. You can also install them on servers in the customer's cloud environment, like AWS, Azure, or GCP. This is useful to access file systems like S3 or ADLS, or databases like RDS or Synapse Analytics. Capacity and performance depend on the size and number of Secure Agents installed. If you need more power, you can scale horizontally by adding more Secure Agents, or vertically by using bigger servers with more memory, CPU, and disk space. You can install the Secure Agent on Windows or Linux. The footprint of the installation depends on the license. Enable services and connectors for the Secure Agent group to have the binaries added to the installation directory. This picture shows the Secure Agent running, with the three core components. The Data Integration Server, Common Integration Components, and Process Server are required to run any integration process. This picture shows the installation on Windows with these three components active. Additional to the three service directories, you see two common directories installed, Administrator and Agent Core. Agent Core is the core component containing the configuration and log files for the Secure Agent. The configuration files can be found in the configuration directory. The main log file, agentcore.log, resides in the agentcore directory. This log file is always the starting point for troubleshooting issues with the secure agent. Each enabled service will also have its log files for more detailed problem analysis. The Informatica cloud-hosted agent is an out-of-the-box runtime environment for integration. It is separately licensed, so it will not be available at every customer. You cannot configure this agent to add or remove services, connectors, or custom options. The Informatica cloud-hosted agent is typically used for cloud-to-cloud integration, for example, to read and write to Salesforce.com or Workday. It is mainly used in cloud application integration, where processes will use APIs and web services to interact with other applications. The Advanced Cluster environment offers more scalability and flexibility. It uses a Kubernetes cluster on the customer's cloud ecosystem to enable distributed processing of the mapping functionality. Mappings must be developed in advanced mode to make use of Advanced Cluster. You need a cloud secure agent on Linux in the customer's cloud environment. This secure agent will not process any data, but manages the lifecycle of the Kubernetes cluster. There are 3 types of Advanced Cluster. The first is fully managed, where the secure agent manages the entire Kubernetes lifecycle. The second is self-service. The customer creates the Kubernetes cluster and the secure agent uses it to process jobs. The third is local. This is a simple, single-node cluster running on the secure agent machine. For more details, refer to the Runtime Environments module. If you don't want or cannot install a secure agent on the customer's cloud environment, you can use the serverless environment. The serverless environment runs entirely in the Informatica cloud. Informatica manages the secure agents and Kubernetes clusters. Each customer will have their own DMZ to ensure the environment is secure. The serverless environment can be enabled for CDI or advanced mappings. When both types are needed, create 2 serverless registrations to the same customer AWS environment, only changing the execution mode. It uses an ENI, Elastic Network Interface, to connect to the customer's AWS Virtual Private Cloud, or VPC. All data access is done via the customer's AWS and the ENI to ensure security. For more details, refer to the Runtime Environments module in this series. Connectors are created in the IDMC administrator and contain the configurations necessary for an IDMC process to read and write to databases, files, or applications. You assign a connector to a runtime environment to ensure the data can be accessed using the most efficient method or protocol. For example, a local secure agent can better access local databases and files to avoid opening firewalls and minimize network traffic. In specific circumstances, you may have created 2 different connectors running on different runtime environments connecting to the same database or application, but this does not happen very often. As mentioned earlier, each connection type has its own configuration parameters. For example, a database connection will use a database user and password, while a Salesforce connection will use a security token, and an Amazon S3 connector uses an access key and secret key. Refer to the connector guide for each connector for details. Database and flat file connectors are packaged with the IDMC license. For other connection types, you may need to acquire a separate license. Time for some exercises. In the following 2 labs, you will install the Cloud Secure Agent on Windows and create 2 connections. Click on the buttons to start the exercise. After you have completed the labs, please move forward to the next section.
In this exercise, you will install the Cloud Secure Agent on a Windows environment and enable the services and connection types needed. Click Download Secure Agent at the top right to start. The download screen comes up. Here you can choose whether the secure agent will be installed in Windows or Linux. We can keep the default Windows. You also see the install token. This will be used to connect the secure agent to the IDMC org after installation. Click Copy to copy the token. The token is copied, so now you can download the secure agent installer. Click Download. The download takes up to a minute to complete. Open the Downloads folder and click the installer to start the installation. Click Run to run the installer. The first step is to choose the installation directory. You can keep the default here. Click Next to go to the next step. The pre-installation summary checks whether there is enough disk space. Note that the space used by the secure agent will increase with the number of services and connectors you enable, and log files will also be written to this location. Click Install to install the secure agent. The installation runs for a few minutes, after which this screen appears. To register the secure agent in the IDMC org, you need the user ID and install token. Click on the username field to enter the user ID. Click on the install token field to paste the token copied earlier. Click Register to register the secure agent in the org. The registration is completed, and the green status bar shows the secure agent is running. But there is more to do. You will have to enable the services and connectors you want to use. Close the secure agent window to return to the IDMC administrator. The secure agent appears in a separate secure agent group in the runtime environment screen. Click on the little down arrow to the left of the group to enable the services. A menu appears with options to show dependencies and manage the secure agent group. Select the option Enable or Disable Services, Connectors. On this screen, you can enable the required services on the secure agent group. It is best practice only to enable what you need. Every service and connector downloads additional executables and will increase the footprint of the secure agents. It will also take longer for the secure agent to start an upgrade. Click on Data Integration to enable this service. In a similar way, a few more services have been enabled. Next, click on the Connectors tab to enable the connections to be used. The following connectors will be used: Amazon S3 and S3 v2, JDBC and SQL Server CDC. Standard database connectors like Oracle or SQL Server are automatically enabled. Enable the Amazon S3 connector by clicking the checkbox. When all required connectors are enabled, click Save to save the configuration. The secure agent will start the enabled services, so the status will change to not all the services are running. After a few minutes, it should change to up and running. This concludes the exercise. Click Next to go back to the presentation. This exercise will walk you through creating two connections, one to a local SQL Server database and one to an AWS S3 file system. In the IDMC Administrator, go to the Connections entry to view all existing connections. Click New Connection on the top right of your screen. Click on the Name field to name the connection C2C_MSSQL_POS. Set the connection type by clicking the drop-down. The list of connection types is quite long, so you will have to scroll down to find the SQL Server connection. Select SQL Server from the list. Depending on the connection type, the properties to enter will vary. First, select the runtime environment which will establish the connection to the database. Select the local secure agent group. The next step is to fill in all the properties, starting with the version. Click on the SQL Server version field to select the required one. All properties are entered, like the server name, database name, schema, and credentials. Let's do a test. Click on the Test Connection button at the top right of the screen. An error message appears at the top of the screen. The code page has not yet been selected. Click on the Code Page field to configure it. Select MS Windows Latin 1. Click Save to save the connection. The connection is saved and ready to use. Click the Close button on the top right to close the configuration screen. You can see the connection in the overview screen. Let's create a second one, this time for AWS S3. Click on New Connection. Click on the Name field to name the connection S3_IP. Select the connection type. You see two Amazon S3 connector types. Select the first one. As you see, the properties are different than for the SQL Server connector. First, select the runtime environment as the local secure agent. You need an access key and a secret key to connect to S3. Your AWS administrator can provide these. Click on the Access Key field to populate it. Next is the secret key. And finally, the folder path. This consists of a root folder, in S3 called a bucket, and, optionally, one or more levels of subfolders. Click on the Folder Path field to populate. The folder path is populated with IPSDE/data. Time to test if everything is entered correctly. Click the Test Connection button. The connection test succeeded. Click Save to save the connection and end this exercise.
Cloud Data Integration, Concepts, and Architecture, Course Summary. In this course, the following topics were covered. The IDMC architecture, the unified platform with multiple services working together. The cloud data integration solutions with tasks and mappings. And, the various runtime environments. Now, it's time for some review questions. This is the first course in the Cloud Data Integration series. Topics covered by the series include concepts and architecture, predefined tasks and mass ingestion, runtime environments, mapping design and development, parameters and dynamic mappings, and hierarchy processing. There will be a comprehensive assessment at the end of the 6 courses. You must score 80% to pass the Cloud Data Integration series. Thank you for completing the Cloud Data Integration, Concepts and Architecture course. Please click the exit button to complete this training.